So in this question we're asked, once there is 1 cubic meter of water or less left in this tank, it's assumed to be empty, how many days does this take? So this is a second follow-up question based on our formula for water leaving a tank. The volume of water at any given hour is given by this formula here. And so we just plug in different values of t to see how much water is left in the tank. And here we're asked basically when is it empty, or when is the answer less than 1. So basically what I would do here is just take v at t and set it to be equal to 1, because once it's equal to 1, we're assuming it's empty. So we're just trying to find at which point in time this happens. And so t is actually our unknown here, and we're going to be working backwards to find t. And so we just set the volume equal to 1, and we're going to be finding the number of hours this takes and then working from hours into days. And so the very first thing I do here, basically because we've got our equation now, which is 1 is equal to all of this, I would multiply across by 3 and divide across by 4, and also divide across by pi. And that is because we've got these constants out in front of 4/3 and pi, which we can just essentially divide across by. So that's all we've done there. And you can see we've now got this expression with one term on each side. So we've got 3/4 pi on the left, and then this thing to be cubed on the right. So the natural next step is going to be to take the cube root of both sides, and that is going to give us this new expression here, where we've got the cube root of 3/4 pi is equal to 10 minus 2 ln t plus 1. And so you can see we're sort of making progress here towards getting t on its own, which is our goal here, because we're looking for how many days does this take, or we're looking for essentially a unit of time, and we need to isolate t to find that. And so this is starting to shape up here, and the next thing I'm going to do is just take away 10 from both sides. So that is going to give us this here. So nothing too different, just taking away 10. And the next thing I'm going to do is divide across by this minus 2. And so now we've got this expression. Once again, nothing too different, just divide across by minus 2. And that actually has also reordered our terms on the left. So now our 10's in front, and we're taking away our cube root of 3/4 pi. But we're getting there now. So our next step is going to be to try and get rid of the log, or the ln function. And so if we just think about what ln actually means, it means that the natural log of x is equal to y implies that e to the y is equal to x. And so we can just use this to reorder our formula to get t plus 1 on its own. And so just rearranging to get rid of our ln, or our natural log, we're going to get that t plus 1 is equal to e to the power of all of 10 minus the cube root of 3/4 pi, all divided by 2. And so I know this is getting to be quite a complicated expression, but the reason I did this is just to make sure that we get an exact answer. I mean, it's essentially, it's okay to simplify into a number like up at this stage, let's say, but I've just done this to basically show that you can do something like this without ever using a calculator until the very last step. But that means that t is going to be all of this minus 1, and so we can just plug this in now, and we're going to get a value of 107.83, and we've got to remember this is a value in hours, because our original function t is measured in hours, or our input for our function v at t is hours, I should say. So now we just got to convert this into days, and so by just dividing across by 24, because there's 24 hours in each day, we're going to get out a value of 4.49 days, or roughly 4.5 days for the tank to be essentially empty in this question. And so that is going to be it for this video.